ladies and gentlemen, welcome to our second debate today on integrated test methodologies. SPI and AOI are central to the machine-to-machine communication, and they're getting used very much in the smart factory environment. They also play a significant role in post-reflow test, and also, of course, in SPI and in AOI before the picking place. This panel is going to discuss a number of strategies for successful design for test strategy. Okay? I'm joined to my left by Dave Bennett from Mertec Corporation. Welcome, Dave. To my extreme left, we have Keith Bryant from Ixelon. And to my right, we have Yara from Saki. And then we have Carsten Sulewski from Viscom. So welcome, gentlemen. Nice to have you here. I'm going to start off with my first question. I'll start with you, Dave, on the end. So the inspection equipment seems to be merging. It's no longer a standalone piece of equipment, but often designed to work in concert with other items of inspection and production equipment. Do you agree with that?
Yes, Trevor. Is this working? Yeah, there we go. Yes, Trevor. I think it's been quite a while now since AOI was just, as it originally was, a policeman. You know, good board, bad board. You know, we use the mantra, the customers don't want us to catch their faults. Mm-hmm. They want us to help them stop making them. And we need to do that by integrating with the whole process. Identifying something is one thing. Being able to tell the customer where it's come from so he can improve his process is by far the most important thing, because that's what they want. You know, nobody wants to be given bad news every day. Yeah. Bad board, bad board, bad board. What you want to do is say, it's a bad board because. And the only way we can tell why it's a bad board is if we can communicate with the rest of the production line.
Right, absolutely. And, you know, it's got to get more predictive in its nature.
Yeah, I think AI is going to be a huge thing in the future. There's going to be far more intelligence in the machines, far more communication between the machines without even needing operators. And we're seeing Industry 4.0, we're seeing things like Connect. There's so many different ways now, and I'm sure every one of us has got some sort of line monitoring feedback way before 4.0 was starting to be promoted. So it's not like it's something new. We've all had it a long time. Some customers already use it. Some are sitting back quite terrified as what 4.0 is going to bring. Mm-hmm, mm-hmm.
Keith, do you have a view on how we're going to be using inspection going forward? It has to be more of a predictive tool, surely.
Yeah, it has to be predictive in the sense that everybody wants to stay within the process window. You know, what we don't want, exactly as David said, is we don't want stuff falling outside the process window, then an alarm going off, and then somebody stopping the line, going to look at it, trying to find out what caused it to fall outside the window. We need to be doing everything we can and said, okay, that's the bottom half of my window, that's the top of my window, and okay, I'm moving towards the top, I need to do something to put me back into the middle. And when we start being able to do that, and we can predict the failures, or we can predict the faults, or we can predict all of that stuff before it actually happens, then we are able to deliver to all of our customers what we would describe as a completely capable process.
Right.
And that involves integration on the whole line, and probably a lot of sensor technology that we don't currently have.
Right, okay. So, Yara, so basically watching or monitoring the system for drift, you know, to make sure it's not trending out of alignment.
Yeah, correct. I mean, our customers demand more and more integration, not only of the inspection devices, but especially related to the process itself. So they are actually demanding some warning systems, which are actually, as Keith said, checking what is the deviation from the standard. Once there is some deviation coming to the end of the process window, they want to take an action. Not only this, but they also want to actually take an action even inside of the inspection program for the neighboring machines, in order to be more, actually to improve the depth of the test on the machine right after, if there was some significant difference in the previous process. So that's why we see the customers are aiming for.
Yeah, okay. Yeah, I mean, Carsten, typically what people have been doing up until now is they have production meetings a week later and say, well, this is how much we messed up last week. What we've got to do is, as I say, get ahead of that, get it into real time. And like Saki, Viscom is one of these companies that has X-ray and AOI and SPI. You have the full suite. So what are you doing to
so yeah, as you said, Viscom is an inspection company for over 30 years, so we've seen a lot of solder joints. And when we're talking about connecting and using the data that inspection systems produce, it was always there. I mean, from in the 80s, you had a disk with the data, but nobody could really use it. So the big difference is today, and we like to see that standardizing or standardization of interfaces, which allows actually to gather all the data. And we can even use all the image data today, which opens the gates for artificial intelligence and online real-time feedback of what's happening in the line. And our systems, test and inspection systems, are key to an Industry 4.0 environment. Right. And I'm very happy to see that that the market is moving there.
Yeah, absolutely, absolutely. Okay, Dave, one thing that's going to help to make things happen in real time is to be able to teach systems faster. How important is that? For setup and changeover?
It's absolutely crucial. The last thing anybody wants to do is spend hours doing programming. We've at the very top of our development will always be ease of programming, and we're currently doing we call it a 2-minute program. And the idea being is that, we joke, we say you could send the receptionist in and she can program the AOI. We're trying to take away the requirement for engineers. We're trying to take away the issue where you've got, there's a term in some factories, I've had people say, oh, I'm the best programmer. Well, we don't want the best, we want everybody to be the best programmer. And the only way you can do that is to have your machine so intelligent that it's doing most of the work. And they are just basically quantifying what it's done and saying, yep, I agree, this is good. And you can do that with a single remote manager. You don't need the best programmer all the time.
Right. No, I agree. Keith, how important is metrology to a test strategy going forward? I mean, we're all talking about Industry 4.0, smart factory. Surely it's going to be data-driven.
Yeah, there's a very old saying, Trevor, if you can't measure it, you don't know what the hell it is. Yeah. Okay. So, yeah, metrology becomes more and more important. As limits become finer and finer, and you want to be able to control your process more and more, you need to be able to measure it, you need to be able to quantify it. We had a chat with Michael Ford, and he was saying, we're still at the stage in a lot of cases of garbage in, garbage out. Right. And, if you're living in that world, then you're never going to be able to get to 4.0. Because until you have very good quality-based data, and to do that, yeah, there has to be a metrology element in some of it, because you're talking about X and Y and Z in real life. Yeah. And, if they are plus or minus too big an amount, then it doesn't work.
Right, of course. No, definitely. I mean, it has to be data-driven, so that it can work and integrate with all the other systems on the line. What's your view on this, Jana?
I mean, absolutely. Talking about the measurement, that's very key, because these days the technology provides for instance, in case of X-ray, volumetry calculations, which you are getting a measurement values which are very close to reality. That means you can actually use them in order to correlate it with the other measurements coming at the beginning of the line, where of course the advanced protocols coming with the Hermes Connect and so on, then it's much easier to merge these kind of data from the beginning and end of the line. So these correlations can then very much define the right process window, and that's the aim at the end.
Right. Carsten, you have SPI, which is obviously a 3D measurement system. X-ray is metrology based also, but you have AOI, which is really image based. How do you work with that?
Yeah, all our systems are algorithm based, so let's not make a mistake. And if you do image comparison, that's not metrology. So you have to qualify a machine and then gauge R&R tests and make sure that it repeatedly measures the same thing. All our systems do that. We do that in 3D SPI, AOI, and in 3D X-ray. But there are also inspections that are more attributes where you extract features, and with a gray level you can actually distinguish between good and bad. So that's so it's not always metrology, but if you talk about metrology, you have to be sure that your system is capable of doing that.
Okay. Okay. So I moved on. Actually, I'll move on to you first of all in this next question, Keith. To maintain line speed, is it better to have an inline X-ray system or stepped up the AOI? Sorry. Is it better to have an inline X-ray system or what do you call it? Standalone. To maintain the line speed, what do you call it? I think my questions got messed up here, but never mind.
No, but don't worry. I understand the meaning of it, and I know why you asked me first. So
right. Okay.
Don't worry. I have a personal view about a lot of this technology. Very simply, whatever you do has to be at the speed that you need it to be done. If you have a tack time on a line building, let's say mobile phones, you know, the fastest that I've seen anywhere in the world is 14 seconds. Yeah, that is fast. 3D AOI can cope with that speed, do a perfect job. If we're all honest with ourselves, an inline X-ray system is going to struggle if there are a lot of components there that are bottom terminated and you need to use the X-ray to get an idea of what they're seeing. Yeah. That's nothing more than a real life situation. You know, we have the automotive industry that is still saying, yeah, we need 100% X-ray inspection because we want to have the reliability and everything else, and they suffer in terms of yield to do that. Right. But if you say, okay, you know, the ultimate is to build the boards as well and as quickly as we can, then the inline AOI system is able to run at a faster speed and produce accuracy faster than compared to inline X-ray. Yeah. And you know, if anyone wants to disagree with me, you guys, you're all welcome. You have microphones, so you know, we can open it up a little bit. But generally, you know, it's acknowledged within the industry that 3D AOI can keep up with the fastest tack times, and a lot of people are putting the X-ray systems now, let's say the high-end automated ones, because they still don't want to have people involvement. Right. You know, that's the 100% X-ray is, you know, people make mistakes. Machines don't make mistakes. So, yeah, if I can have 100% X-ray, then I'm really happy.
Right. Yeah, well, I mean,
you're looking my direction, and I disagree. Yes.
And I smile. Yeah.
Okay.
No, inline X-ray, even 3D AXI, can keep up with line speeds. I mean, you're talking about mobile phones or something that size. If you do a multi-up panel, our new system right now has handling times that are as short as any AOI system, so it's below 5 seconds. So we did a lot in the mechanics to really utilize the time available for 3D X-ray. And that's, so, I mean, we can show you. Come over and we look at it. But it still complements each other. Right. I mean, this system that I'm talking about has a 3D AOI sensor and 3D AXI in the same system. Right. And it simultaneously can inspect optical and X-ray, so two parts at the same time. So there are concepts, there are designs that allow 100% 3D AOI and 3D AXI. And I agree with that part. 3D AOI can keep up with today's line speeds, no problem.
It can keep up, but is there a trade-off between, say, an inline X-ray and, say, a standalone in terms of quality? Because you're trying to do it fast.
Image quality has improved in inline systems a lot, not only with us, but same we saw in 3D AOI image quality over the years. I mean, we have great images today that looks like, you know, you needed a long time in a laboratory 10 years ago to get something like that. You get that in line speed, and we do the same in 3D X-ray now.
Right. Yeah. Yaroslav, yes. You're dying to jump in here. I can see.
If I can just a few words. Okay. I mean, the full inline X-ray, I think it's important. from the perspective that the 3D AOI can make a dynamic depth of test control of X-ray. Okay, so by controlling the AOI process, I mean, by monitoring the board deviations, the measurements, we can dynamically change the depth of the test on X-ray. It not necessarily needs to be one machine. I mean, that can be two machines standing next to each other, but cooperating in a way to be like one machine. Right. And I think that's the way we should consider how the machine can influence the time spent on the next board in order to, okay, if everything is under control, if there is nothing in the warning, if all of the statistics is matching the targets, it's not necessary to go in depth on inspection on X-ray. On the other hand, if I see some deviations in 3D AOI, I spend a little bit more time to investigate more in deep in 3D, for instance.
Right.
So I see the future in this kind of dynamic balancing of the cycle time. Of course, it requests to have a very good integrated programming in order to make this balancing efficient and fully automated. That's why we aim.
Yeah, no, I understand what you're saying. But I mean, Dave, is the other approach to this not to let the AOI do all the hard work and do that, because it's fast, so it can do all the grunt work and then really focus down to the area of concern.
Yes, I think, I mean, at the moment, the perfect machine is the super high speed AOI, AXI, that's faster than any production line in the world. And if that exists, why doesn't everybody have one? The truth is that most people realize that the best X-ray is offline, the best AOI is inline. The trouble is you have to somehow merge them. So maybe taking the best offline with an operator and making it inline. We've got Industry 4.0 coming. That supposedly means every machine can talk to every machine. If that's the case, for me, the future is probably development of very high-speed inline X-rays that will connect to any 3D AOI, whatever the badge.
Right. Okay. Well, so basically, I mean, I know you've been doing some work with
Exelon, yeah.
Exelon, Mr. Exelon here, on a smart loop system where basically you hone in on the area of interest.
Yeah, we find the
comparative.
problem.
And we're going to talk also, Viscom has got a system as well for doing overlay and looking at the different strategies. Yeah. But so what you're doing is basically doing all the hard inspection, the fast inspection, bringing it down to an area of interest, and then bringing it offline to standalone. Is that essentially what we're looking at with Smart Loop?
Yeah, I mean, pretty much. I mean, 3D AOI is brilliant. With the Moray and the other stuff that they've got now for doing Z height measurement, they can produce really, really accurate results. They can produce nice maps of actually contours of some of the warped or coplanarity issued components. Yeah. But obviously AOI is the same as our eyes. What it can't see are the joints underneath. And that's the difference. It can say, okay, if it's got good accurate measurement, and all of the guys sitting around here have very good accurate measuring systems. They can tell you, okay, the component is warped by this amount. Then you take that to the X-ray machine. The X-ray machine looks at the joints, and it says, okay, it's warped by, let's say, 7%, but all the joints are still good. Right. Therefore, I can now adjust the parameter of my inspection to make that a pass. Because if I've looked at enough of the warps at 7%, and they've all passed the X-ray because all the joints are good, then we know that even if this particular component, and I'm only just picking numbers out of my head, I can see you looking at them and thinking 70 degrees is big, and yeah, it is big, but I'm just coming up with numbers. Yeah. So if you have a number X, and you've looked at 100 parts, so you look in your MIS system, and it says, yeah, we've checked 100 of these, every one of them has good joints, you can now alter the parameters of your 3D inspection so that becomes acceptable, and again, you're working within this window, which is the whole thing that everybody's looking to do. Yeah. So yeah, interconnectivity helps with things like this, and to use an offline machine means the operator can do more time, they can investigate, they can look and see, and they're not driven by the holding up the production line or having to work within the window.
Right.
Still not really in agreement.
Okay.
But you
okay.
divided it into offline X-ray and 3D AOI and the inline X-ray guys. Of course, we come from a little bit different world, but there is inline 100% inspection. X-ray is possible today, and we see 3D volume representation in inline systems that were not possible years ago. Mm-hmm. So there's a certain change, and that's why we believe that inline 3D X-ray is even not improving, but it's being available in higher numbers even for consumer electronics and others.
Yeah.
So that,
Carsten, you also have an integrated test strategy where you can compare the AOI with the SPI and the X-ray.
Yeah, we call that quality uplink. So since we have all the test gates, we use SPI information and AOI information and 3D X-ray information for the operator in the verification station. The more information you get to really classify a found defect, that avoids that the operator just accepts something that's not okay. So more information is helpful here. And that's also where automated processes come into play, where we assist the operator not to make a mistake, because we have all the information available and we can we can share it between the systems. And not only Viscom systems. Our uplink also works with other SPI systems and takes the data and presents it to the operator post-reflow. Right.
Jaroslav, does Saki have any integrated system strategies like this?
Yeah, sure. We have, of course, as my colleague said, the integration of the process is very important. And I just would like to, what Dave said a few minutes ago about the Industry 4.0 initiatives. And, these days, connectivity is pretty simple. I would say companies are open to speak to each other and so on. That's fine. But one of our concerns, what we see is, what is the quality of the information which is transferred over? And that's something which we try to actually define the environment and define the machine conditions with a inspection data conditions, which actually should assure that the information which is transferred under the Industry 4.0 name is reliable and it is reproducible in a way. So it's very important to understand not only the connectivity is applicable or it's possible now, but also the question is how about the quality of the information coming in, because maybe the third-party system will make a decision for you later, which in certain extent can be dangerous. So therefore we released a system called quality-driven production, which is trying to define the environment around every single software option or the machine or inspection process, which is actually defining these conditions, what kind of information we are transferring. And of course, we have a system of multi-process connectivity. It means seeing AOI, SPI, X-ray on a single screen for the operator to help him to judge, including all of the measured values, including volumetric calculations and shape information.
Great. Well, it seems like you've all got solutions for an integrated test strategy. So we're actually starting to run out of time, so that brings us to the end of our debate today. It's always nice when we have people that have opposing views. It makes it a bit more interesting. So I want to thank our panel, Dave Bennett from Murtec Europe, of course Keith Bryant from Exelon, and Jaroslav Neuhauser from Saki, and Carsten Saluski from Viscom. Okay? And thank you for joining us today. Thank you.